Are you looking for a simple and economical way to grow and refeed cells, spheroids, organisms in suspension, maintain suspension cultures in BSL-2 containment vessels, spin large numbers of miniature rotating bioreactors simultaneously, expose cells to physiologic fluid shear stress to enhance differentiation, image and assay spheroids still in suspension without transfer to a 2D environment? See what cell SPINPODs could do. In a rotating suspension culture vessel with no headspace, no air bubble, particles, shown here as blue beads, sediment under the influence of gravity, but are continuously brought back up into suspension as the vessel slowly spins. As the vessel spins, the cells are exposed to physiologic, low fluid shear stress uniformly throughout the culture. This fluid shear stress is an important physiologic stimulus to maintain the differentiation of many cell types. It also serves to gently bring in fresh nutrients and carry away waste products while preserving the 3D architecture of the cells or spheroids. Cell SPINPODs are small. They are 44 millimeters in diameter and hold 3.5 milliliters, which economizes on expensive cells and reagents. They are radiation sterilized and ready to use. Cell SPINPODs are easy to load through their self-sealing silicone ports. A needle in the second port allows the air to leave as the cell SPINPOD is filled. These self-sealing ports also provide BSL-2 containment. Cell SPINPODs rotate on an ordinary, inexpensive laboratory bottle roller. Because cell SPINPODs have optically clear gas exchange membranes on both sides of the cell chamber, you can monitor the cells by microscopy without removing them from the vessel. This is a fluorescent microscopy image of cells still in a cell SPINPOD. Immortalized renal cells were grown on a microcarrier bead in a rotating cell SPINPOD and stained with a green fluorescent viability dye. The bright field image is on the left, and the fluorescent image is on the right. You can even add reagents to the cell SPINPODs and assay the cells in situ. This image shows SPINPODs in an incubator that have been injected with fluorescein conjugated albumin to measure uptake by cells in rotation. In the upper left corner of the image are SPINPODs with fluorescein albumin lying flat as static controls. At the end of the culture period, the contents can be aspirated into a syringe, or the membrane can be incised and the contents harvested with a pipette. To learn more, visit our webpage at cellspinpod.com for more information.